Well, good morning, everybody. My name is Liz Farrington. I'm the marketing manager at Centre City, and I'd like to welcome you to our Engineering Plastics for the Future webinar in partnership with igus. For those of you who don't know, Centre City is a global innovation hub which specialises in sensor and IoT technologies, but we're also heavily involved in rapid prototyping and digital fabrication. We have on-site labs with over £1 million worth of equipment. We have an engineering team based with us, and we have event space and office suites also for innovative SMEs to be based from. Our hub is in Liverpool, and while we do usually run an active events program on site, we have run a number of webinars throughout lockdown. But we're pleased today to be here with another session with igus. So igus are producers of motion plastics, and while plastic as a material does have some growing environmental challenges, there are many positives and innovative solutions that are coming out of using this type of material. So today we will be reviewing the industry applications of motion plastics, particularly within the automotive sectors, but also looking at the different component parts and benefits that using this material has over others, including metals. We are joined by two guest speakers today from igus. Firstly, Justin Leonard, who will give us an overview, followed by Chris Foote, who will give the main presentation. We do encourage you to ask questions around what the speakers are saying. If you could please use the chat function, then the speakers will address each of these points afterwards, and we can engage in a Q&A session. If I could ask if you could all put your microphones on mute, this will help to remove any background noise, but do use the chat function to post questions. Equally, we are hoping to record the session today, but if you do have any objections, please let us know now. So, but without further ado, I would like to hand over to Justin. Thank you.
So good morning, everybody, and thank you for joining us. My name is Justin Leonard. I'm a director of one of the product streams at igus in the UK, which is our cable and cable management division. And I will be giving you a bit of an overview of igus, what we're about, because we're a company that many people have not heard of, but we're quite key in our industry. And then the second part of the presentation will be given by Chris Foote, who is our business development specialist, and he'll be talking more about the detail of some of these plastics. And as Elizabeth said, we will be glad to answer any questions. It'll be really helpful if you want to put them in the chat as we go, or indeed keep them for the end. But it'll be great to hear what you think and discuss and answer any questions that we have towards the end. So what I will now do is I'm going to share my screen, and let's get into the initial part of the presentation. And what I'd like to do today is to give you an introduction to igus. I'm going to make the assumptions, so please forgive me if any of this is familiar to you, but I just want to give you a bit of an overview of the company, why we exist and what we do, and also a little bit of a background to how we ended up in motion plastics and what even motion plastics means before we get into the detail. So this is the company igus. We're headquartered in Cologne in Germany, a German parent company, family owned and still family owned. And the root of the name, it's an unusual name, but the root of the name, so the I is for the word industry, and the gus comes from the word spritzguss, which is injection molding. So it's about industrial injection molding. That is what our name is kind of a byword for. So where do we start? Well, we started in 1964, and our founding father, Gunter Blaser, there's a photograph of him there, and his wife Margaret, and they started the company in 1964. And by trade, Gunter was actually a specialist in woodworking by his training and by his education, but he could see that even at that stage that plastics offered a huge opportunity for engineering. Now, at that time, plastics were starting to become an important part of consumer products because of all sorts of things, and they were kind of quite new and sexy and interesting because you could make all sorts of shapes and so on and so forth, but were not being taken seriously at this stage as an engineering material. And this is something that we pioneered, and Gunter could see the benefits that there could be. And Gunter started the business with a small in a double garage, and had a small injection molding machine. And he went round to local businesses and started talking to German businesses about what are the problem parts they had that were made from metal that needed lubrication. And this is a crucial part of what we'll talk about in a moment. And he would solve the problems for them using plastic. And the first part that we solved this with is this pin that you can see here that was originally in metal and needed lubricating, and we made this with self-lubricating plastic. Solved a lot of problems, and this was for a company that made carburetors for engines, and we still supply to that company today, albeit on things like fuel injection units and other parts. And there was a second company around the same time that was involved in manufacturing textiles. And again, the problems they were having was because of greased parts. The textile fibers were getting into the parts and causing very large amounts of wear. And we solved that problem with plastics. And that's how the company started. And fast forward now, we are a business with 3,500 employees. We're in 37 countries around the world, subsidiaries such as the UK, still family owned. So Gunter's son now is the CEO of the company. And we are still on this mission, but we've expanded it out into very different area. So or rather very much broader areas of business. So now we've gone from these two little plastic parts to a full range, a full catalogue of parts. And we broadly describe these into two divisions of the business. One is what we call the chain. So this is based around plastic energy chains. An energy chain is a device for carrying moving cables and hoses. So where you have anything from cranes to accessibility lifts, vehicles, anything that moves on machinery, from the large to the very, very small, we will safely carry the cables and hoses and keep them protected and guided. In addition, in the 1980s, we developed a range of cables because we discovered that standard cables don't like being constantly flexed and moved. It's a very niche area because most cables, such as the ones you'll have domestically, are used for very light flexing or static use. And we discovered that they really weren't suitable for millions of movements as you get in a lot of machinery. So we developed a range of what we call chain flex cable. That's a brand name of ours, and of course they're flexible cables to go in chains. And that was something we've developed a full range of industrial cables now, and we guarantee these for 10 million movements or 3 years, which is a very high cycle life. And these are quite different to the kind of cables you have statically around a building, or that you would have for very light duty use domestically. These are for really long-term use in industrial applications. And of course, then we extended that into offering these cables connectorized, so with all the relevant connectors for industrial use. And then, of course, we build that up into a system that you see at the bottom of this slide here in the middle, where we now supply the energy chain fully populated with cables and hoses and connectors ready to go onto machines. So this rig here could be rolled up to a 4-axis machine tool system and simply offloaded straight onto the machine and wired up, which saves huge amounts of time on the production line. And that's the kind of thing that we can do. So we can supply from the components through to full subsystems. The other half of our business is based around dry running bearings, which is more akin to what I started with, where the company started. And the idea again is these are plastics, but they're plastics that really have 3 components, the same as the chains. They have a base plastic, which is what gives it its form, fibers in most cases to give us the strength, and then a solid lubricant, which is what gives the self-lubricating property. And what we mean by solid lubricant is something that doesn't leave any kind of residue and means that you don't need to grease that product. And we start off with bushings at the top here. So these would be pivoting parts, these offering anything within machinery that pivots, and Chris will be giving some examples of those later, some quite high-tech ones. Spherical bearings, these are where something has misalignment within a machine, and we take out that misalignment by using a spherical bearing. And you'll see 2 different colors here in these, with the black and the yellow parts. They're both plastic. They're just differential plastics to offer that performance. By the way, the different colors that you see in our ranges so that we can identify the different properties. So some are for high or low temperatures, high chemical resistance, radiation tolerance, all sorts of things. And this is our way of identifying them. We then moved into linear systems. This is what we call Drylin. That's our brand name for this. So instead of, again, conventionally having something like ball bearings moving in a system up and down on a rail, we would do this with a plain plastic bearing, which is, again, self-lubricating. So you don't need to have grease in that system at all. Moving on, in more recent years, we've developed out into all sorts of other areas. At the start of the discussion, Elizabeth mentioned additive manufacture being something that Sensor City involved with and having in their facility. Additive manufacture is something we're entering into as well. So we can take our special plastics but put them into either filaments or SLS powders to allow a true bearing, a true self-lubricating bearing product to be made using different kinds of 3D printing. And we always also manufacture that in things like bars and tapes so that you can machine up individual parts for prototyping, or indeed put tape, self-lubricating tape onto another surface where you might have high friction or high wear. We've developed things like rotating systems. Again, traditionally, slewing rings would have ball bearings in them with grease, and we take that out and we offer a system that is then dry running, and that opens up a whole other area of field that we'll talk about in a moment. And then plastic ball bearings. So please understand what I mean by that is not the balls. The balls can still be stainless steel, but it's where there's no grease required in the race, in the cage inside here, and that offers us the ability to make very light self-lubricating things like roller assemblies. We've moved into automation, and so we have these low-cost automation units, so small robots, very, very lightweight, because again, everything is based around plastics, and low cost, both in the form of robot arms or in the form of Delta robots. Very easy to program, very simple, and usually at a fraction of the cost of the current alternatives, and indeed just linear axes as well. So where simply you have to put the control law in and the power, but the motor with or without any kind of gearbox or other attachments, we just supply pre-built, and we can do those as single linear axis up to 2 or 3 axis gantry sort of system. So really the whole bones of an automation system can be supplied ready to go. And notice that with all of these things that it's all about motion. Everything we do is to do with motion, and that's why we talk about motion plastics, is that it's about moving. For static applications, we're not into molding static parts. Our specialism is in these self-lubricating plastic parts. More recently, we've developed a lot of different kind of helix systems for spindles, for motion again that we can drive, so we can have either belt driven or indeed lead screw driven systems as well. And again, all the same principle where you see these yellowy kind of plastics, that's our self-lubricating plastic, so light, corrosion free, but above all needing no lubrication. We also work on, so as well as sort of OEM applications for repeat business, we also work in the project sphere, where we develop one-off project solutions for customers. So for example, here, this giant ring you see here, this is because our cable chains, our energy chains, like as I've shown on this slide here, cable management, we can also produce those, believe it or not, to run in a circle as well as in a linear way. And this is a system that is something like 26 meters radius, and a huge system. And we developed this specifically for cranes that go out onto vessels. This is a few off built for some very specialized vessels where the cranes needed to rotate and have their power systems completely reliable and running without any slip rings. Slip rings being one way of transferring power, but this was a much better solution, much more reliable and straightforward. So this is an example here. The middle example is within a theatre. So this is what we call a zigzag system that can move either underfloor or overhead in things like theatre or stage applications, where moving lighting gantries move up and down, or set moves up and down. And again, we provide all the cable and cable management into those in a slightly different form. So again, a very project-based system. And you can see by the diagrams, we support that with full design turnkey, from design to installation kind of support. And then I mentioned with the gantries that we can offer 1, 2, 3 plus axis gantry systems using our self-lubricating systems. And these are a couple of examples of systems that we've developed for customers ready to drop in and drive all of the moving componentry on their machines. So as well as individual components, we go right up to this systems approach. In 2016, we started to move into another area, which was looking at what we could do with our plastic parts and systems to help with the move to Industry 4.0. In other words, or the connected factory, or the Internet of Things, the industrial Internet of Things, depending on your terminology. And for us, this is actually a very logical next step for us. So as well as offering warranties with our parts, because we test them to destruction, we know how many million cycles they'll take, and we can guarantee that. But actually, the next step is to put sensors into the plastics, embedding sensors in, so that customers have a very clear indication of when the part is a certain way through its life, or indeed if it's in an exposed environment where it could get damaged by the industrial application, where it can stop the machine instantly before something gets really damaged. So we have all sorts of different sensor systems that look for whether things like the energy chains are broken or the cables are failing because maybe a product has fallen into the application and damaged them. And it can stop the machine instantly to prevent further damage, and can alert engineers via SMS or email or anything you want. Or it can also be embedded into a cloud-based system where you can constantly monitor these components within your factory and see maybe where they are in their lifetime. And that's a really interesting next step that very high value manufacturing, so for example automotive industry, is really taking up this area, because of course downtime is very critical and very expensive. But more importantly, it's a very good thing for sustainability, because it means that traditionally, I mean, factories would maybe replace these parts after a certain time in their life, but now you don't need to do that until they really are truly at the end of their life, which means you get more life out of them, and that's a more sustainable approach. So that was just an overview on in terms of igus, how we started, where we came from, and our current product stream, and where we are. So I'm now going to hand over to Chris, who'll pick up, and we will then explore more about what this means for sustainable plastics.
Good morning, everyone. My name's Chris Foote. I've been with igus, this is my 20th year now. And I'm really just going to run through the basics of why use plastics in industry. So engineering plastics for the future. Yes, we know there's a lot of bad press about plastics, but we're going to run through all the good points and what we feel we are doing to help going forward. Efficiency gains relating to energy can be achieved in many ways, and they can be achieved in many ways. Obviously, there's some big pluses for plastics. They're lightweight, they're easy to machine. But how can we go forward? How can we move forward with plastics in industry? Something we come across a lot of the time is, and this is a true statement for a lot of people, certainly from the older generation, those who know plastics use metal. There's still a lot of the older generation that won't look at plastics because metal. It's the way to go. It's been used historically. People won't change. So plastics as a structural part we'll cover. Plastics as a highly loaded machine element, and how are the environmental effects of plastics? Firstly, something very simple but very true. Steel is 8 times heavier than plastic. Definitely true. And as we go along, that will become apparent as to why we've put that in there. Obviously, copper, bronze, steel, cast iron, even aluminium, way more than plastic. Airbus, one of the applications for plastics that makes it more efficient to use a plastic. Obviously, this is a carbon fiber coated with plastic, but it's a 25% lower fuel burn and reduces CO2 emissions. Now, we're not saying we're going to save the planet by doing this, but it's certainly helping by reducing the CO2 emissions. And this is going forward through a whole range of industries, automotive, down to your toilet door, believe it or not. Oh, sorry about that, bear with me. Automotive, definitely a big industry for igus. Obviously one of the first parts, or the first part we ever produced, was for automotive. And again, a 25% weight saving. Sorry that the right hand side's in German. This will make everything more efficient. The whole unit is lighter. That means the car is lighter. That means there will be less power needed to move that car. A strange one, but true. Football shoes made of plastic. 70% plastic and weigh only a third of shoes from 10 years ago. There is an argument that they don't protect the player as much, but they are lighter, giving freer movement. But that's fine. But what about moving parts, high load parts? Can plastics, polymers cope with this type of thing? Well, there's some true facts. igus are very big in the automotive industry, but also very big on the internal side of planes. We do a lot with seating, the cabin equipment, that type of thing. But going through those facts, I'm not going to read them out to you, you can see them. But obviously the bottom one, 7.5 tons less of CO2 a year by switching to plastic bearings within the seating elements. So you've gone away from your typical DU bush, your metal backed PTFE bush, or your brass or light type bush, and switch to plastic. That is the saving on one plane flying a year. Now that adds up. Wow. Dirt. Why use a plastic bearing in so much dirt? Surely it's going to wear away. Well, actually no, because in certain circumstances, you're not attracting the dirt to the bearing as you would with grease. You're also not getting it trapped between balls. When a ball bearing will collapse, it takes the shaft out straight away. So 2 weeks life of a ball bearing in this environment, 4 months with a plastic bearing. So already we're now saving, well, that's going to be 5, 6, 7 times more to produce those metal bearings. Now remember, going back to the previous slide where it costs a lot more to produce a metal part than it is a plastic part, massive savings for the environment. Also a lot less downtime for the customer. Excavation equipment. Nobody in their right mind would put a plastic bearing in the pivot, but they would, because they work, and they work very, very well, and they work a lot longer, going back to that previous slide, because the dust and dirt, depending on what material you use. Now let me specify something here. We have a range of 64 different materials. We have to get the right material, but I'll come to that in a bit later. But plastic bearings do work very well in very, very high loads. We've got bearings that can go up to 150 which is a very, very high load. And also shock loads. We can take shock loads. Metal bearings can't cope with shock loads. Something has to give, either the bearing or it digs into the shaft. So again, there's a saving there. If we can make these pieces of equipment last longer, there's less metalwork shafts needed to be produced, be replaced. Then we come to something that Justin touched on, 3D printing. It's a relatively new thing for us. I would say about 3-4 years. We've got a range of filaments and also SLS. Now, again, there's a big saving in doing this because you've not got any waste. You use the material you've got. And with the SLS, if it's not used once, it goes back in, used again. But obviously, we can now do very, very specialized, tricky parts. All we need is a step file and away we go. So certainly the future, maybe not totally outdoing molded parts, but we're certainly going to move forward in a big way in this field. And it's certainly something industry wants us to do. So going back to what I was just saying about choosing the right material, you can see a range of materials on here. We've got 64. There's only a small range here. You can see some wear from shafts of other bearings, shall we say. We do a lot of testing, and to do those testing, we need a laboratory. And this is how many tests we do a year on average, 135 billion test movements. This means we can predict the life of our bearings, which again is a big cost saving for the industry, because we can give the right bearing that will last the longest, most cost effective price. What we don't want to do is give somebody a bearing that's, wow, amazing, but doesn't last long. That's no good for anybody, and it certainly doesn't help us with wear, which obviously we want to keep down to a minimum, which helps the environment. 300 tests permanently in parallel running tests. A lot of these are on the energy chain, which Justin spoke about. These will go backwards and forwards. In fact, we've got one energy chain that, if I'm right in thinking, has now been running over 35 years, just going backwards and forwards. And obviously almost 11,500 tests tribological. And that is where we are developing new materials all the time. I think this year we brought out 3 new materials. One's UV resistant. So obviously for the solar industry, that's going to be great, because that will sit in a field for many more years than some of our standard bearings, which can be affected by UV rays. And again, the longer these bearings last, the better it is for the environment. And as you can see, results directly online for our experts. If anybody wants any help with these at any time, please contact us or go through Elizabeth. We can help people choose the right bearing for the right application, and the chain and the cables. These are the tools, very easy to use, all online. You don't have to log in and register. You can go online and use these tools for free, or you can give one of us a ring and we'll go through it with you. Very easy to use, but give you a very good indication of what bearing or what chain, what lead screw system you should use for your application. Motion plastics. How are the environmental effects of plastics? Well, this is a big topic. It's something that we as a company have moved forward with very quickly over the last 5-6 years. We've seen that we needed to change the way we did things, and we reacted very quickly. And it wasn't to pressure from outside. It was something we wanted to do anyway. Before making the materials, obviously it comes from a base. Plastics are oil based. We have to make sure we get the most out of these plastics. We have to make sure that we recycle what we don't use. So if you've got an 8-cavity tool, we have to recycle the sprues. If you've got machine parts, we have to make sure that these parts can be recycled. Energy balance of different materials. So you can see how much it costs in energy to produce steel, aluminium, roughly the same. Plastic, it's a lot less. A lot less. Same thickness, complete energy chain, energy saving. With this chain, you've got the same thickness. You've got a very strong part, but literally half the cost to produce. Half the cost to produce. And remember, this is a steel chain. This is sat outside for a while. Even if it's galvanized, it will start to corrode. The elements will affect it. With our energy chain, it won't be affected as much. They don't absorb as much moisture. They don't corrode. They're vibration dampening. These are all plus points. Automotive. Use and lifetime. Now, everyone knows that you have to recycle a certain amount of plastics that come out of a car. Most of our parts don't fall into that category, but we put them into that category. We can recycle all our plastics. All our plastics are recyclable. Yes, you might have to group them together, because depending on what goes into it, the fiber, the reinforcement, that type of thing. But yes, we can recycle them. Weight. Again, going back to the weight that we discussed with the airplane. 1 gram for plastic bearing compared to 5 grams for metal bearing within the automotive industry. Now, we're not talking sports cars here. We're talking general, normal cars where you can have a bearing in the foot pedal. You can have something in the steering column, maybe the boot hinge. We can take weight out. We can make these cars more efficient. Something that was a surprise to me about 3 weeks ago when I first read this. PET bottle is the best in comparison. Now, most people will think, let's go back to glass. But then you've got to move it. You've got to make it. and then you've got to recycle it. Doing this with plastic is a lot cheaper, a lot more cost effective. Certainly within the transport industry, it's a lot lighter to transport. And these are facts coming from the German Nature Conservation Society. So, you know, we're not crossing swords with people. These are facts. So again, look at plastic. And this, again, was something very surprising to us a few years ago when we first learned about it. 22.7 million tons of lubricants end up in the environment every year. If you grease a bearing, it will need re-greasing and re-greasing. And the more that bearing runs, the dirtier it gets. People don't clean the bearings out and re-grease them. They just throw more grease at it. And the effect becomes less and less and less, but you're still throwing the same amount of grease at it. With a polymer bearing and a solid lubricant, that doesn't happen. If you choose the right bearing, it will wear 1 micron in the first week, maybe. It will wear 1 micron in the second week, 1 micron in the third week. But the percentage of lubricant is always the same. You don't need to grease it. In fact, we don't want people to grease it because it can affect the bearing. And also, all you do is attract dirt, which again is a bad thing for a bearing. Sustainability. We need to choose the right bearing for the right application, but as you can see, the wear rates here, 30 MPa, 0.01 meters a second pivoting continuously. Our bearings survive very, very well. The wear is very low, but as you can see, the wear on the shaft is also very low, if at all. So there's a cost saving to be had on the bearing, there's a cost saving to be had on the shaft, and also these will last longer. So you take the rolled metal, i.e. the DU type bush, compared to Iglador Q, we're looking at maybe 6-7 times longer that's going to last. That's a big saving for the environment. Going back to what we said about how much energy it takes to make a metal bearing, there's a big saving there. But as you can see, plastics, and this is where it's got a bad press, there's a lot of waste plastic. A lot of waste plastic, and we create this as humans. What can we do as a company? We can recycle. So igus, approximately 2 years ago, set up a scheme where we will take back anybody else's energy chain or anybody else's plastic material, as long as we know what it's made from, and get it recycled. Now, most of this will get recycled into playground equipment, surfaces, roads, that type of thing. But it's getting recycled. And we're doing that off our own back with other companies, which I'll come to in a minute. Plastic to oil. We can take the oil out of the plastic. Very clever way of doing it. Way beyond my intelligence, but it can be done. And we can get a certain percentage of oil out of that plastic. What's left will go back in and be made into other things. igus this year has had 4.7 million investment with in Mura Technologies. Now, these are the guys that are basically recycling plastic, not necessarily ours, but any plastics. And we will get more and more involved in that over the years because we have to. We can't afford to let the world think that plastics are bad. You can't do anything with them. Once they're done, they just get thrown on landfill. No, we have to recycle things. And going forward, that's exactly what we're doing. Now, that's that bit. The right mix. So, as long as we get the right polymer into the right application, this can be the bearings or the chains, we can make them last longer, run more efficiently. That is the right mix. What we don't want to do is people go in and go, right, there's a plastic bearing, they choose the wrong one, it lasts 5 seconds, it takes the shaft out, bad for everyone. So that's why we keep investing in more and more different materials, more and more different chains, more and more cables, and always moving forward. So the 3D printing, that will be very big for us, although it already is, but it will get bigger and bigger and bigger. The right data. Going back to the testing, the more testing we do on our materials, the better the world can understand them. We'll understand them, you can understand them, and we get the right material in the right application. We have bearings out there that have been running for 20 years. Plastic bearings that run for a very long time. And great innovations. As Justin said, we're now getting heavily into robotics. We're now going into iSense, Industry 4.0, where we can monitor the wear of the bearings online. You can see how much this bearing is wearing. Predictive maintenance then comes in. You've not got crashes that take parts of larger pieces of equipment out of condition. They all have to be replaced, the shafts, the cogs. We're helping to try and save that. And that's the future, a nice, clean environment. Now, I just want to go back to my screen. So hopefully you can all see that little blue bearing in my hand. That is an FDA EU compliant bearing. That can be used in the food industry. Why am I showing you that? One of the most expensive greases to produce is for the food industry. It will most probably take 3-4 times more to grease a bearing cost-wise in the food industry than it does on a piece of farm equipment and things like that. That will save a lot of energy in producing grease. It'll also last a lot longer than a metal bearing, which sometimes can't always be used in the food industry. That's an innovative part that igus have developed. We'll keep developing new products. Obviously, we do it with customers. Most of our products are developed with customers, and then we put them into the field. I hope that's given you a very simple feeling of what igus are doing and how we're progressing as a company and trying to be as forward thinking as we possibly can, but still using polymers. Now, if anybody has any questions, or Justin, if you want to come back in.
Yeah, so I'll step back in. So what I'd like to do is share my screen, and then I'll answer. There's a couple of questions come in, so thank you to Phil and Matthew for your questions, and I will answer those in a second. I just wanted to share my screen again to show something in terms of our website, so we can see this here. So a couple of things that I wanted to talk about. First of all, sustainability and this is directly from our website. You can find this on igus.co.uk/info/sustainability, one of our key topics. And this talks about a couple of areas which I just think are useful extensions of what we've been discussing. So first of all, to highlight that both in Germany and also in the UK, in our own right, we have ISO 14001 2015 environmental management standard. And one of the things about this standard, if you've ever worked with the ISO standards, most people know ISO 9001 for quality, 14001 is the environmental standard in the same way. And the thing about these standards is they force you to be progressive. You can't stand still. You always have to be getting better and better. So there's a good page here which offers some more discussion here about the sustainability that we aim for. And again, just put some overview bullet points against these and why this is important. One other thing to highlight is when we develop new products, so this year we've launched a whole load of new products, over 100 new products. Every product has 4 key elements that we describe about it. So one is the technology up. What is the benefit for you as a customer for our product? What is the technology benefit? Also, we describe if there's a cost down, how we evidence that from the igus laboratories and the long-term lab tests that we do, but crucially also the sustainability element. So for example, one of our new industry 4 products here, we would clearly describe what the technology up benefit is, what the cost down benefit is, what the proof is from our labs, but also the sustainability element of that product and why it is better. So for example, the knowledge of the service life, because it's a predictive maintenance part, means premature replacement is avoided, and so on and so forth. Chris also touched on the green chain recycling program. So for plastic energy chains like ours, that they can be returned to us and we will recycle those. And we have a process for that that we clearly give about how to clean them up, weigh them and send them back to us. And we give a voucher back to purchase parts from us. And finally, and this will hopefully answer one of the questions. So if I just go back into this, one of the questions that we had here was from Matthew. What are the objectives of the investment that we make with Mura? Well, there's a page on here which is igus.co.uk info plastic to oil. This page here describes what we're doing, and the point about the Mura technology work is that there is a catalytic process which can take basically turn plastic back into oil, which is a really big game changer. And up to now, that's been a very energy intensive process, but there's some really clever work going on now to make that so that it's a very sustainable process. And I think rather than me sort of going through that in detail, I think that's a really good page. So I'll paste that into the chat, Matthew, and hopefully that answers. But ultimately, what we're trying to get to is kind of a circular process with plastics, because the key thing about plastics ending up in the environment, and of course, I suppose one of the things we should note is that plastics getting into the environment is predominantly consumer plastics. That's where most of what we see is. It's consumer parts, and that of course has to be addressed. But even for industrial parts is important. But if you can break this, in fact, if you can have a cycle where it runs in a completed cycle, back into oil and then back into plastics again, then yes, of course there's an energy element, but of course we've just explained that is a lot lower than for the equivalent metal parts. But if you do that, you take them out of circulation into the wider environment, and that's really ultimately what the goal is about there. So again, Matthew, I'll just paste that in to answer that question for you. I'll put that in now. There's another question we had, which is a really good one here, actually, from Phil. What are the safety benefits of using plastics compared to other metals? Compared to other materials, rather. So if I just, I'm just going to put the screen back up to one of the slides here to give you an example of that. So the key thing is here that when let's take a very simple example of a plain bearing. When a plain bearing runs on a shaft, then if the plain bearing deforms, or because it comes under an edge load, or because of vibration or fatigue, it will actually damage the shaft. But crucially, if it dries out, if there's not enough lubrication, or it damages the shaft like that, the whole system can actually stop working completely. It can just seize up. So you're absolutely right. There is a safety element depending on what the machine is doing. The same thing with ball bearings, or any kind of spherical or roller bearings that are greased up. Again, if the grease attracts dirt and the dirt seizes the bearing just stops dead. And whatever that machining operation is, it could be in a medical unit in a hospital, on an X-ray machine or a scanner. It could be on something within a car. It can just seize. And there is a safety element within that as well. Now, typically plastic plain bearings will not seize up, because there's no moving parts to seize up. There's no ball bearings to seize up. So what happens is the bearing will gradually wear over time, and will gradually break down over a very, very long period of time, but it doesn't have the catastrophic failure that you get often with metal alternatives. And going back to the same thing with the cable chains, if I can find another slide just to show what I mean by that. So looking at the cable carriers, again, if these are made from metal, if something takes a side load, an edge load, a bending load on it, so here, take one of these here, for example, in steel, that will deform and stay deformed. And I've seen this happen with some cases where metal chains have been used, where the system has bent and then has tried to move, and as it moves, it catastrophically fails. And all of the nuts and bolts that hold this together, because it's made up of several parts per link, become like shrapnel. They can move very, very fast, and we can cause a seizing of the machine, but worse still, we can cause parts flying off. With plastic, the beauty of plastic is that it has an intrinsic flexibility. It has some spring in it, some give in it, which means if it comes under loads that you don't expect, it won't shatter or bend and stay deformed. It will deform and move back again because of an intrinsic elasticity that it has, which means it's far less likely to fail catastrophically. So again, hopefully that answers the question for you, Phil, about the safety benefits of that, because of the intrinsic flexibility and so on. Wendy, thank you for your question. How much abrasion of parts do you get on these moving parts? Does the plastic get more rigid with age? Okay, so two different questions there. So in terms of the abrasion of parts, yes, absolutely, that is how the system works. You do get an abrasion of parts. Basically, plastics wear in a very linear way. and there's an initial wear, which is where the plastic coats the surface of the shaft or the running surface running on at a very microscopic level. So you kind of have almost plastic running on plastic. So there's an initial abrasion. But then after that, plastic wears in an incredibly linear way, which is why we can offer warranties with our parts and guarantees over how long they last, because it's incredibly simple to work out. As long as you've got lots of test data, which we do have, under certain loads, certain temperatures, certain conditions, you can see how it will wear and how long it will last. But that's expected. But having said that, the lifetimes we're talking are very, very large indeed, usually for the life of the machine. We do offer line replaceable parts, but actually there's very little. Usually things will last over the lifetime of the machine. Does the plastic get more rigid with age? So you're talking about the sort of things like UV effects. Well, no, if it's specified correctly for the right application, it doesn't change property over the life of it. And this is one of the beauties of, for example, a plastic bearing over a metal alternative, is that it's not a coating, it's homogeneous. You have the same plastic all the way through. So as it wears, the properties stay precisely the same over the life. Now, of course, because of the abrasion, you eventually get a level of clearance, which is maybe not, which eventually becomes unacceptable for the application, depending on the application. But that is very predictable. But no, it doesn't change as long as we as long as we select the right part. Then there's no issue with that. And we have a lot of configurators online. Chris touched on this, which allow you to put your speed, your load that you're taking, either for bearings or indeed for our energy chains, and they will predict very accurately the lifetime. You can get a certificate immediately back that tells you what the guaranteed lifetime is, so that's good. We had another question here. What medical sector use case of motion plastics can we share with you? Okay, that's a really interesting one, and that one is really very, very open. So if I go back to our this slide here. So if I go back to the start where we can talk about the product groups themselves. So for cable management systems, this can be everything from patient beds, so the motorized beds that lift and lower will have small cable management systems in them to carry the power sources, scanners, so everything from scanning systems to treatment systems that usually have rotating scanners in them will carry plastic parts. Of course, a benefit there is that some of these MRI systems, you don't want metal in them anyway, so plastic systems are really good because they don't get in the way of the different kind of scanning technology rays that are being used in those as well, or magnetic systems as well. Plastics work well. We have them in X-ray systems within hospitals, where you want to move rather than having an X-ray. A good example we've done in some hospitals around the UK is where you have an X-ray system, which you would traditionally have one X-ray system per room in an emergency in the A&E area. But actually, they've now got them where they've got multiple booths, and the whole system is moved around from the ceiling, for example. So you can use the same bit of kit to work with different patients very, very quickly between the rooms. And that is a system where we often supply power and data using our cable management systems into those kind of environments. On the bearings, again, myriad of uses. Anywhere where there's a pivot point, everything from screens to beds to again the same scanning and treatment systems, and in fact right down to prosthetics. We have some bearings that go into things like prosthetic limb joints, and of course the saving there is really obvious then, because you don't need to grease the part, which is the last thing you want to be doing on a part like that. But also it's very light. So again, if you're trying to have a prosthetic part, of course you want that to be as light as possible, otherwise it's a real burden for the person using it. So again, every gram that you can save by using something like plastic bearing for the life of the product becomes very, very important and very valuable.
Can I just share my screen?
Yep. Okay.
And if you want to go for them, feel free.
Yeah, thank you very much. So there's yes, a good point Chris makes. So we have an industrial on our website. There's an industrial page, and that you can click on any industry and see the different kind of things. So the orange parts here are kind of touching what I said here. So you can find lots and lots of examples here. So Chris, if you just click on the prosthesis and orthesis page. So for example, if you go to the this page, you can see, scroll down a bit, and then you can see actually multiple specific individual applications. So if you go a bit further down, I think we will actually have some of the products that are used, and there we are, some of the actual applications that are here. So our web page is full of applications. I've just touched on the very top level there. But if you go to our home page and go to the industry page, you can click into any industry, and we will show you hundreds of applications that exist there as well. One more question that we've had: a plastic bearing could be used as a toy in its second life. And what about the third life? And what's the percentage of customers that send their plastics back for recycling? Okay, so two parts to that question. So thank you very much for that. Actually, I think there's maybe a misunderstanding there. So the plastic bearing or the chain can be used as long as the condition's good and it isn't contaminated. Actually, we can use that within our own range of products for its second life. So we actually have a number of materials which are used for less demanding applications and less highly toleranced applications, which can be used from a high component of recycled material. So actually, the second life, we would try and do as much of that as ourselves within make the second life actually again as an igus product. And then as you go further back, you can use it for other things. But again, we're trying to tackle this in a very really to take a huge leap over that question and go straight back to taking plastics back to oil. And that's why we're investing in the plastic to oil. I showed you the web page there, because with plastics to oil, you go right back to the component and start again, and then you can use it in any fashion at all, rather than maybe the traditional view of plastics at the moment, which is that you have to, and the same with metals, by the way, with recycling, is that the grade gets less as you use it, which is what your question alludes to. So we're trying to sort of completely sidestep that and actually go back to a more primary use again by tackling this at source with the plastics to oil. So I think that's all of the questions that have been asked. So thank you for those really good, really insightful questions. Actually, thank you. That's really good, and a lot of those questions really do cut to the nub of what we're tackling here. So again, if I just may jump back in one more time to share the pages, so I can show you how to find things on our homepage. So if you go to the igus.co.uk page, I've touched on our new products and where you look for these symbols, you can see the green symbol. When you look at About Us, you can find the environmental pages here, which talk a little bit about sustainability and what we're trying to do. And from here, you can find more information about, for example, the plastics to oil and some of the other things that we're doing within the company, as well as the recycling program here, ISO 14001. So some of the key things are all found from our igus.co.uk About Us page. And the other thing which I wanted to touch on, because we had some really good questions about industries, if you click on solutions and then look at industry sector, you can see all of the different industries here. So for example, medical technology is one of the ones that we looked at. We can look at things like automotive industry, and if you click into these, we will show very clearly the kind of products, the benefits, and what kind of areas, both for automotive production, but also products on vehicles. And then as much as possible, we're trying to give examples that we either generic examples of where the products can be used and what their benefits are, and in many cases we can give specific ones as long as we have the commercial ability to do that. So so that's under solutions, industry sector. Going back to the medical one as well, as that was one was asked for. Again, we give some highlights, some key things, that key technologies and what the benefits are, and then we go into for example, specific applications wherever we can give those. So hopefully that gives you the core places you maybe want to look at on our homepage, which will help you learn more and find out more about how these things work. So with that, thank you very much. Elizabeth, I'll hand back to you then.
Yeah, well, thank you very much, everybody, for getting involved in the webinar today, particularly Justin and Chris for sharing their expertise. If you do have any further questions that you didn't ask today, please do either email them through to myself And if there's enough interest, I'm sure we could sort of develop further webinars in the future, which are relating, to specific areas rather than an overview. Whether you're specifically interested in safety, durability, maintenance, cost of motion plastics, is definitely areas that we could focus in on and run further sessions. I think today's webinar has really been very interesting and kind of broadened my awareness of kind of diversity of the technology and the applications of motion plastics. It's really interesting to see the kind of 3D printing, robotics elements, and even the more slightly unusual use cases in football boots, maybe in theatrical applications, as opposed to sort of core industry implementation. While plastics, not the overall solution maybe, but they're not the overall enemy either. It's great to see kind of forward-thinking and innovative ideas coming out, which can certainly help with kind of positive contributions overall to the environmental factors. Thank you again for joining. We have recorded the session today. I don't think there were any objections, so I will host it online and I'll share the link to you all so you can access it again, or for anyone who was unable to join us live, they can catch up in their own time. If you did enjoy the session, as I mentioned, we did previously run a number of other webinars, so links to those are also on our website, which is sensorcity.co.uk, and also I'll share the links to those in the follow-up email. So thank you again. Hopefully you can join us for future events, whether that's back on site in our innovation hub in the coming months, and we could potentially do some live demos. You can kind of get up close, have a look at all the different products and see how they would benefit any prototypes or products that yourselves are developing. Or equally, if you're keen to run any other webinars, do let us know, and we'd love to sort of tailor the content in line with our audience's interests. So thank you very much again. Enjoy the rest of your day. And that's it from City and igus. Thank you.
Thank you very much.